Class example 3.4.3. For each graph, we want to know, does it describe a relation? Is that relation a function? And we're going to find the domain and range. In the next example, I go through a little bit more detail, the difference between interval and set notation. So if you need that extra detail, you can jump ahead to the next lesson and then come back to this one. In the meantime, we're going to talk about, does the graph represent a relation? And a relation is just a mathematical connection or relationship between two variables or two items or an input and an output. And whenever you have a graph, we have relations. So both graph A and B are relations. This one is a straight line, this one is a circle, and that's okay. We talk about a function. We say that a function is only going to have one output for every single input. So we can see that this first line here, if I was to go along the x-axis, I can only see one output here for each one of these. So yes, graph A is a function, but graph B is not. In graph B, I can see that I've got multiple values for the y's, for individual values for x, and we know that that's not going to be a function. So only graph A is a function. For the domain, we are going to see that we're going to have a closed dot here at -2, -3, -4, -5, -6. We have an open dot at positive 1, 2, 3, positive dot at 3 here. And so we can see that our domain is going to include all values of x between -6 and +3, excluding +3 itself because it has an open dot. Our range for this first graph is going to go, it looks like -4 all the way up to +5. So the range includes all values of y between -4 and +5, excluding -4 because of that that open dot. Okay, so that was us describing it in words. And once you describe it in words, the rest of it becomes a little bit easier. So interval notation for graph A. So this is graph A. This is graph A. Okay, we've already talked about the domain and the range. Again, like I said, we are going to go in a little bit further detail as to the difference between interval and set notation in the next lesson. So in this particular case, if you're getting the hang of it, that's awesome. We always start with the smallest number. In this particular case for the domain, it's -6. Our largest number is +3, and we've written that down so we don't have to go further than that. We did not include +3, but we did include 6. So we have a square bracket around the -6 and a round bracket around the +3. Our range, we went from -4 up to 5, but we excluded -4. So a round bracket around the -4 and a square bracket around the +5. If we are going to do this in interval notation, we usually have a D in front and an R in front. We say that x such that is going to be, x is going to go in between the lowest to the highest values there, just similar to that we had in our interval notation. We're going to use inequality symbols instead. If I have a square bracket, it means it is included. If I have a round bracket, it means it is not. And then we say that x is going to be an element of the reals. I talk about these in further detail in the next lesson, next example. And y, we're still going to go from smallest to largest. We are not going to include the 4, so in our inequality symbol, we do not put an equal sign, but for the 5 we do, and that y will be an element of the real number system. For graph B, which is the circle one, our x values along the x-axis are going from 1 to 7. So we can say domain includes all values of x between +1, to 7, and they are inclusive. And the range includes all values of y between, and it looks like we're going from the lowest point to the highest point of -3 to +3. Okay, so if we are in interval notation for the domain, we start with the lowest number and we go up to the highest number. That's an interval there. And we're inclusive of both, so we're going to have square brackets around both. And our range is going from our smallest value to our largest value, again, including both. If we are going to be doing this in set notation, then we are going to open up our squiggly lines. We're going to say x such that, start with the lowest, end with the highest. We've got x and we've got inequality symbols that are inclusive. And so we put the line on the bottom. Because it's a solid line, we write x as an element of the reals. For our range, we have y such that we go from the lowest to the highest. It's inclusive for both of them, and such that y will be an element of the reals because it's a solid line.